In this video, we're going to discuss the last two rules for calculating the derivative. Um, we have a lot of rules. We've never talked about when our functions that we want to take the derivative of involves the product or multiplication of two functions. And we've not talked about when it includes the division or the quotient of two functions. And so this section, we're going to talk about what we call the product and the quotient rules. Let's start with the product rule. The product rule basically states that if I have a function that's multiplied by another function, multiplication is product, I use capital F here for first and capital S here for second, then the derivative of that product is the derivative of the first function. So I'm going to say f prime of x times the second function plus the first function times the derivative of the second function. And remember, every time that we state that these are differentiation rules or derivative formulas or rules, remember what helps us get here is that we're doing the derivative of our average rate of change over smaller and smaller. We're doing the limit of our average rate of change formula over smaller and smaller intervals, right? This is sitting in the background, and what mathematicians have noticed is that the formula, if you do this for any function that involves a product of two functions, it simplifies to this thing right here. So it's the derivative of the first function. Let's actually write that out. And so I'm going to delete this or remove this part, and we're going to write out this kind of like in a statement. It's the derivative of the first times the second plus the first times the derivative of the second, right? So, or you can say it the other way around, right? You can say it's the first times the derivative of the second plus the second times the derivative of the first. When I learned it, this is how we said it, but this is what your textbook gives, and so that's fine, all right? And so when you have a product of multiplication understood to be between two functions, you have to use this rule here. You cannot take the derivative separately. What I don't want you to see is, like in an example like this, I'm going to write this in red, right? Let's say we have this example and I wanted to take the derivative. Well, the derivative, all right, does not equal, oh, I can take the derivative of the x squared, that's 3x squared, and I can multiply that by the derivative of the ln of x, which is 1 over x. That is incorrect, incorrect. Don't ever do that, right? It's actually a lot more complicated than that. We have to use that derivative formula. And so my first function, I'm just going to come off and do some scratch. My first function is x cubed, and my second function here is the natural log of x, right? And so when I do my derivative, I'm going to say f prime of x is the derivative of the first function, which is 3x squared, times the second function, which is ln of x, plus the first function, so I'm just going to copy it down, times the derivative of the second function. The derivative of natural log is 1 over x. And so notice this is x cubed over 1, and so one of the x's cancel. So I can simplify this and say that that's plus x squared, all right? It's actually not a need to write this out because we can kind of see what's first and second. So I'm not going to do that in this next example. All right, I have f of x equals 5x times e to the x, right? Well, I can see that my first function is 5x and my second function is e to the x. So I'm ready to take the derivative. It's the derivative of my first function. Derivative of 5x is 5 times my second function plus my first function, I just copy it down, times the derivative of my second function. Well, the derivative of e to the x is just e to the x. And so there's my derivative. It is completely simplified. I don't have to do anything else to that example. I've used the product rule to help me find this derivative. Let's go to part C here. I have negative 3x natural log of 5x squared, right? So notice here, negative 3x will be considered my first function. And remember, the natural log always has to have an input. And the input of our natural log is not just an x, but it's a 5x squared. But I have two functions. This is my first function, and this is my second function. I'm actually going to write that out this time. Because sometimes people think ln is just by itself. ln by itself means absolutely nothing. You always have to have an input for your natural log function. Now, This is going to be a little difficult because when I take the derivative of the natural log of 5x squared, I have to remember that this requires a chain rule. All right, and it requires a chain rule because that's not just the natural log of x. And we already know the chain rule, so we'll take care of that when we get there. And so now that I know what my first and my second functions are in this product, I'm going to go ahead and take my derivative. It's the derivative of the first. The derivative of negative 3x, since it is linear, is negative 3. And I multiply that by my second function. Plus, I just write down my first function. Now notice that's a negative 3x, so I'm going to put it in parentheses, times the derivative of my second function. Again, when I do this derivative here, I've got to use the chain rule, right? Now, in my chain rule, my inside function is 5x squared, and my outside function is what I do to that 5x squared, which I take the natural log of it. And so my outside function is the natural log of x. Remember that when we use the chain rule, our chain rule is O prime of I sub x times I prime of x, right? So I've got to do the derivative of the outside function, which is 1 over x, but I've got to include that inside function. And so it's going to be a 1 over 5x squared. And I've got to multiply it by the derivative of my inside function, which is a power rule with that constant multiple. So that's going to be times a 10x. And so if I wanted to make this look a little nicer, I'll have a negative 3 natural log of 5x squared. This negative 3, actually that's over 1 and that's over 1. Since this is a fraction, I'm going to make all of these fractions. And so what I see here is I have a negative 3x times 1 times 10x. That's a negative 30x squared. So I have a negative 30x squared divided by 1 times 5x squared times 1. That's a 5x squared. And so I can simplify that to minus 6 because those x squareds cancel. And so that is our example there. So sometimes you may have a chain rule or different rules within the product rule, but you have to be able to notice that pattern to help you calculate the derivative. And so that's the derivative in this example here. The quotient rule is a division of two functions. And notice we have a top and a bottom. I know it's denominator and numerator, or numerator and denominator, but I'm going to use t of x as my top function, b of x as my bottom function. Again, that limit that I talked about earlier, I erased it, so I'm sorry. But that limit as h approaches 0 of f of x plus h minus f of x all over h allowed us to get to this formula here. This equals, it's your function on the bottom times the derivative of the top function minus your top function times the derivative of your bottom function all over the bottom function squared. All right. The way I say this in words, all right, I'm going to come over here. It's bottom times the derivative of the top minus top times the derivative of the bottom all over the bottom function squared. All right. Some people call the function on top high, the function on the bottom low. It's low d high, low d high, low, the function on the bottom times the derivative of the top, the high function, minus high d low over the bottom function squared, or low low. All right. Now, those are different statements. I just remember bottom times the derivative of top minus top times the derivative of bottom all over the bottom squared. Be sure that you know the order in which this numerator is written, because since there's a subtraction, you can't switch the order of these two multiplications here, right? So I can't put t, the top times the derivative of the bottom first, minus the bottom times the derivative of the top, right? Now when I was, let's set that in stone. Now, when I was doing my product rule, because there's a plus sign here, I can do first times the derivative of the second plus the derivative of the first times the second, or I can write it in the order that I have it here because that's a plus sign between them. I can't switch this order across this subtraction symbol here. So you need to remember this formula in this manner. All right. So we can look at the top function and the bottom function. So I'm not going to necessarily write those things down, but let's go ahead and take the derivative, right? And so again, that's my t of x, and the 1 plus x squared is my b of x, right? And so by this formula, by my quotient rule, I take my function that's on the bottom, which is a 1 plus x squared, and I multiply it by the derivative of the top function, that's t prime, right? Well, the derivative of x cubed is 3x squared. Minus, I'm going to write down my top function, which is x squared, x cubed, sorry. And I'm going to multiply that by the derivative of my bottom function, which is the derivative of 1 is 0, and the derivative of x squared is 2x. And I divide that all by the bottom function squared. So that'll be 1 plus x squared squared. So I have the bottom times the derivative of the top minus the top times the derivative of the bottom, all of the bottom squared. Now, I definitely want to simplify. I don't want all this multiplication and subtraction. So I'm going to use my distributive property here. I get a 3x squared plus 3x to the fourth minus a 2x to the fourth. What we're never going to do is multiply this out. Just keep this as a 1 plus x squared squared. And so when I combine these two terms here, 3 minus 2 is 1. So I get x squared plus x to the fourth over 1 plus x squared squared. We could try to factor this, but it's not going to simplify or cancel with my denominator. And so we can keep this completely simplified. Okay, let's look at another example. F of x equals x over e to the 3x plus 1. Now note here that we have a top function and a bottom function, right? I'm ready to take my derivative. It's the bottom function, which is e to the 3x. That's a plus 1. That bottom function times the derivative of the top, right? The derivative of x is 1. It's a linear function. Its slope is understood to be a 1. Minus my top function times the derivative of my bottom function. Well, if I look at this, this is actually a chain rule when I look at e to the 3x. It's a chain rule because it's not just e to the x. So if I look at e to the 3x and I want to do its derivative, I have an inside function, which is 3x, and my outside function, which is e to the x. Remember, we want to do e o prime of I of x times I prime of x. And so its derivative, that's the x here, is the outside function's derivative. Well, the derivative of e to the x is e to the x, but I've got to put the inside function. So it's going to be e to the 3x, and I've got to multiply it by the derivative of the inside function, that's this part right here, which is 3. So I've done the bottom function times the derivative of the top minus the top function times the derivative of the bottom, all over my bottom function squared. When I multiply by 1, I get the same thing, right? So my numerator, e to the 3x plus 1 minus, this is just all multiplication. I'm just going to bring this 3 out front. So I'll say minus 3x e to the 3x. Now, both of these terms, let's go ahead here. It looks like you can combine this last term with this first term, but you can't because there's an x here. So this is completely simplified. And so that is my derivative using the quotient rule. Last example that we're going to look at in this video is y equals 1 over x squared. Now, what you could do is you could apply the quotient rule because I have a x in my denominator. However, when we looked at this example before, what we would do is we would write this as x to the negative 2 power, right? Now, when we write it this way, if we want to find our derivative, all we have to do is bring that 2 out front, or that negative 2 out front, and reduce our exponent by 1, and we get negative 2x to the negative 3. I wanted to show you this example because this is very easy. But we could also do this using the quotient rule, right? If this is my top, t of x, and this is my bottom, or b of x, then if I want to find my derivative, you do the bottom function, which is x squared, times the derivative of the top. Well, the derivative of the top is a constant, so that is derivative is 0, minus my top function times the derivative of my bottom function, all over my bottom function squared. I'm going to get a 0 for this term and a negative 2x on my numerator. And when you raise the power to a power, you multiply the exponent, so that would be x to the fourth. And I can actually simplify this because this is x to the first power. I can write that as 2 over x cubed, which is exactly the same here because we could write this as negative 2. And if we didn't want that negative exponent there, we'll have x cubed, right? So just because something is in the denominator doesn't mean that you always have to apply the quotient rule. It's easier to do the power rule. However, if you do apply the quotient rule in an example like this, you will still be correct. All right, but this is our quotient rule, and this is our quotient rule here, and we also have our product rule where we have a first and second function multiplied by each other, and that concludes our video. I'll see you in the next video.